Human-computer interaction, lecture note, Cambridge Computer Science Report Part 2, Alan Blackwell. Overview of contents, Lecture 1, the scope and challenge of HCI and instruction design. Lecture 2, visual representation, segmentation, and variable of the display plane, mode of correspondence. Lecture 3, text and gesture interaction, evolution of interaction hardware, measurement and assessment of novel methods. Lecture 4, inference-based approaches, Bayesian strategy for the data entry and programming by example. Augmented reality. Lecture 5, augmented reality and tangible user interface, machine vision, fiducial maker, paper interface makes reality. Lecture 6, usability of programming language and user programming. Programming for children, cognitive dimension of notation. Lecture 7, user-centered design, research, contextual observation, prototyping, ticketing, alert protocol, qualitative data in the design cycle. Lecture 8, usability evaluation method, formative and summative method, empirical measures, evaluation of the Part 2 project. Lecture 1, what is HCI or interaction design? With the exemption of the embedded software and operating system code, the success of the software product is determined by the human who use the product. This note presents theoretical and practical approaches to making successful and usable software. A user-centered design process, as taught in earlier years of the Tripos and experiences in many group design projects, provides professional resorts to creating software with functional that user need. However, the availability of the technical functionality does not grant that software will be practically usable. Software that is usable for this purpose is sometimes described by programmers as intuitive, easy to learn, easy to remember, easy to apply to the new problem, or powerful, efficient, effective. These terms are vague and unscientific, but they point in the right direction. This course presents scientific approaches to making software that is intuitive and powerful. HCI helps us to understand why some software products are good and other software is bad, but sadly is not granted formula for creating a successful product. In this sense, it is like architecture or product design. Architect and product designer need a true technical grasp of materials they work with, but the success of their work depends on the creative application of this technical knowledge. This is creativity is a craft skill that is normally learned by working with a master designer in a studio or from case study of successful design. A computer science course does not provide sufficient time for this kind of training in creative design, but it can provide the essential element, an understanding of the user need, and an understanding of potential solution. There are many different approaches to study and design of the user interface. This course attempts so far as possible within 8 lectures to discuss the important aspect to the field including interaction design, user experience design, UX, interactive system design, cognitive ergonomic, man-machine interface (MMI), user interface design (UI), human factor, cognitive tag design, information architecture (EA), software product design, usability engineering, user-centered design (UCD), and computer support collaborative work (CSCW). This investigation required a wide range of academic style, extending across all the parts of the university. Lack of familiarity with the other kind of investigation and analysis can make it hard to absorb or collaborate with other perspectives. The veterans of different disciplines can range from those that are interpretive to those that are scientific but are necessary. The first criticized as soft and the second as reduction, and each relying on different kind of knowledge, with supposition of those seen as relativists at the extreme or positivists at the other. In professional work, the most important attribute for HCI expert are to the both creative and practical, placing design at the center of the field. Notes on the recommended reading. The recommended reading for this course is a follow Interaction Design Beyond Human-Computer Interaction by Helen Sharp, Fiona Roger, and Jenny Price. Second edition 2007 describe both theoretical approaches and practical professional design method and the forefront of the current practice. HCI models theories and framework toward multidisciplinary science, edited by John Carroll 2003, provides an in-depth introduction to the most influential theoretical approaches across the HCI field. Unfortunately, the publisher has let this book go out of the print, but there are still many copies around Cambridge. Research Method for Human-Computer Interaction is a new text edited by Paul Cairns and Anna Chalks, Cambridge University Press, 2008. They explain the nature of HCI research and the range of method used within the context of academic HCI from the UK perspective. This is not refer to specific chapter in this book for more detail on the specific topic. Lecture 2. Visual representation. How can you design computer display that is meaningful as possible to human viewers? Answering this question requires understanding of the visual representation, the principle by which marking on the surface are made interpreted. Not many illustrations referred to this section are easily available online, with a variety of the copyright restriction. I will show as many possible in this lecture itself. If you want to investigate further, Google should find most of the tools mentioned. Typography and text. For many years, computer display resemble paper document. This does not mean that they were simplistic or unreasonably constrained. On the contrary, most aspects of modern industrial society have been successfully achieved using representational convention of the paper. So those conventions seem to be powerful one. Information on the paper can be structured using tabulate column alignment, indentation, and emphasis, border, and shading. All of those were incorporated into computer text display. Interaction convention, however, were restricted on the operation of the typewriter rather than the pencil. Each character type will appear at a specific location. Location could be constrained like fill, box, and paper form. A shortcut command key could be defined using on the screen, label, or the paper overlay. This is not as text itself, but keyboard interaction with the text that is limited and frustrating compared to what we can do the paper. Shalon and Harper 2002. But despite and the constraint on the keyboard instruction, much information on the computer screen is still represented as text. Convention of the typography and graphic designer help us to interpret the text as if we are on the page. And human readers benefit from many countries of the refinement and in the text document design. Text itself, including many reading system as well as specialist Notation such as algebra is a visual representation that has its own research and educational literature. Documents that contain a mix of bordered or colored regions contain picture, text, and diagrammatic elements can be interpreted according to the convention of magazine design. Poster advertising for form design, textbooks, and encyclopedias. Designer of the screen representation should take care to properly apply the specialist knowledge of the tools graphic and typographic profession. Position on the page, use of typographic grid and genre-specific illustrative conventions should all be taken account. Summary: most screen-based information is interpreted according to the text and typographic convention, in which graphical elements are arranged within visual grid, occasionally divided and constant with the rule and color border, maps, and GURPS. The computer has, however, also acquired and specialized visual vocabulary and convention. Before the text-based glass teletype became ubiquitous, cathode ray display were already used to display oscilloscope wave and radar echoes, but they could be easily interpreted because of their correspondence to existing paper convention, and oscilloscope use a horizontal time axis to trace variation of the quantity over time, as pioneered by William Playfair in his 1796 chart of the British economy. A radar screen shows direction and distance of object from central reference point, just the Harvard map mundi of the 1013 1300 organized place according to their approximate direction and the distance from the Jerusalem. Many visual displays on the computer continue to use this ancient but powerful invention. The map and the GURP in particular, the first truly large software project, the Sage Air Defense System, set out to present data in the form of the augmented radar screen, an abstract map on which symbol the text could be overlaid. The first graphic computer, the Lincoln Laboratory, wherein was created to show maps. Next text. Summary: basic diagrammatic convention rely on the quantitative correspondence between a direction on the surface and continuous quantity such as time or distance. This should follow established convention of the map and GURPS. Schematic drawing. Ivan Sunderland groundbreaking PhD research with the whirlwind successor TX2 introduced several more sophisticated alternatives. 1963, the use of light pen allowed users to draw arbitrary line rather than relying on the control key to select predefined option. An obvious application in the engineering context of MIT was to make engineering drawings such as Ginder Bridge C-figure. Line on the screen are scale version of the actual grids, and the text information can be overlaid to give detailed force calculation. Plans of this kind as a visual representation are closely related to map. However, where the plane of the map corresponds to be continuous surface, engineering drawing need not be continuous. Each set connected component must share the same scale. but the white space indicate an interpreted break. So the independent representation can potentially share the same defined surface, a convention introduced in the Derot Encyclopedia of 1772, which showed picture and multiple objects on the page but cut them loose from the any shared pictorial context. Summary engineering drawing convention allows schematic view of connected component to be shown in the relative scale and with the text annotation labeling the part. White space and the representation plane can be used to help reader distinguish element from each other rather than directly representation physical scale picture. Sunderland also suggested the potential value the computer screen might over the artistic tools. His sketchpad system was used to create a simple animation cartoon of the Winky Girl. This is this is the first computer visual representation that might suffer from the resemblance fallacy, e.a. the drawings are able to depict real object of the scene because the visual perception of the flag image simulates the visual perception of the real scene. Sutherland Sutherland cartoon could only be called an approximate simulation, but many flat image photographs, photorealistic ray trace rendering, oil painting, have been described, and the two perceiving the representation is equivalent to the perceiving a real object. In reality, new perspective rendering conventions are invented and estimated for the accuracy by critical consensus and only more slowly adopted by untrained reader. The consensus on the preferred perspective shifts across culture and historical period, as is obvious from comparison of the prehistoric, classical, medieval, and Renaissance artwork. It would be naive to assume that the convention of today are the final and perfect product of the technical evolution. As with text, we become so accustomed to interpreting this representation that we are blind to the artifice. When even the psychological object recognition experiment employ line drawing as to their object, it can be hard to insist on the true nature of the representation, but professional artists are fully aware of the convention they ask. The way that the photograph is framed change its mean, and a skilled pencil drawing is completely unlike visual edge detection threshold, and good pictorial representation need to not simulate visual experience any more than a good painting of the unicorn need resemble an actual unicorn. Summary: pictorial representation, including line drawing, painting, perspective rendering, and photograph rely on the shared interpretive convention for their meaning is naive to treat screen representation as though they were simulation of experience in the physical world. Note and the link diagram. This first impulse of the computer scientist when give a pencil seemed to be draw boxes and connect them with line. This node and the link diagram can be analyzed in the terms of the guard structure that the fundamental to the study algorithm. but unrelated to the visual representation known as graph of the or chart. A, a predecessor of this connectivity diagram can be found in electrical circuit schematic, where the exact location of the component and the length of the wires can be arranged anywhere because they are irrelevant to the circuit function. Another early program created for the TX2, this time by Ivan Sutherland Broderberg, allowed user to the creative circuit diagram of this kind. The distinctive feature of the node and link connectivity diagram is that since the position of each node is irrelevant to the operation of the circuit, it can be used to carry other information. Marian Petra research into the work of electronic engineering 1995 catalog the way in which they positioned components in a way that were meaningful to human readers, but not to the computer. Like the blank space between digital objects from the secondary notation, use the plane to assist reader way to not relate to the technical content. Circuit connectivity diagrams have been most widely popularized through the London Underground diagram and the invention in electrical engineering, Henry Beck. The diagram has been clarified by exploiting the fact that most underground travelers are only interested in the order and connectivity, not location, of the station on the line. However, populace resistance to reading diagram mean that the one is more often described as the London Underground map despite Beck complaints. Summary: note the link diagram is still widely perceived and being too technical from board acceptance. Nevertheless, they can present information about understanding the relationship clearly, especially if consideration is given to the value of the allowing human user to specific position. Icon and symbol. Maps frequently use the symbol to indicate specific kind of the landmark. Sometimes they are recognizably pictorial, the standard symbol for the tree and church, but other of the fairly arbitrary convention, the symbol for the railway station. As the resolution of the computer display increased in the 1970s, and greater variety of the symbol could be differentiated by making them more detailed as in the MIT SDMS system that map naval battle scenario with the symbol for different kind of the ship. However, the dividing line between picture and the symbol is ambiguous. Children drawing house often use conventional symbol: door for windows, triangle roof, and chimney. Whether or not their own house has two-story or the fireplace. Letter of the Latin alphabet are shaped with a completely arbitrary relationship to their phonetic meaning. But the Korean phonetic alphabet is easier to learn because the form mimic and the shape of the mouth when the pronouncing the sound, the feel of semiotic over sophisticated way of analyzing the basic on the which mark corresponding to meaning. In most cases, to be approaches for an interaction design is simply to adopt familiar convention. When these do not exist, the design task is more challenging. It's unclear which the designer working on the Zero Star coined the term icon For the small picture symbolizing different kind of the system object, David Canfield Smith winningly described them as being like religious icon, with he said were picture standing for abstract spiritual concept, but icon is also used the technical term in semiotic. Unfortunately, few the Seros team had a sophisticated understanding of the semiotic. It was fine art PhD Susan Kerr design work on the Apple Macintosh that established a visual vocabulary which has informed the genre ever since. Some general advice principles are overlaid by authors such as Horton 1994, but successful design of the icon is still sporadic. Many software publishes simply opt for the memorable brand logo, while others seriously misjudges the kinds correspondence that are appropriate. My favorite blooper was software engineering tool is which a pile of coin was used to access the change command. It has been suggested the icon being pictorial are easier to understand than text, and that preliterate children or the speaker or of different language might terribly be able to use computer without being able to read. In practice, most icons simply and add decoration to the text label, and those that are intended to be self-explanatory must be supported with textual tooltips. The early Macintosh icon, despite their elegance, were surprisingly open to misinterpretation. One PhD granted of the my acquaintance believed that Macintosh folder symbol was briefcase. The folder tag looked like the handle, which allowed her to carry her files from the place to place. When the place inside, although mistaken, this belief never caused her any trouble, and correspondence can work so long as it is applied consistently. Summary: the design of the simple and memorable visual symbol is the sophisticated graphic design skill. Following established convention is the easy option, but the new symbol must be designed with awareness of the short correspondence is intense pictorial symbol metonymic each key represents looking bizarrely mnemonic, but probably not monolingual fonts. Visual metaphor: the ambitious graphic design of the Zero Star, Alto, Apple Lisa, Macintosh were the first Macintosh were the first mass market visual interface. They were marketed to the office professional, making to the cover story that they resemble an office desktop, a convenient explanatory device. Of course, as was frequently not at the time, this interface behaved nothing like a real desktop. The mnemonic symbol for the file deletion, a wastebasket, was ridiculous if interpreted as an object placed on the desk, and nobody could explain why the desk had window in it. The name was derived by the clipping windows of the graphic architecture used to implement them. It was at some later point that they began to be explained as resembling sheet of the paper on the desk. There were immediate complaints from luminaries such Alan Kay and Ted Nelson that string analogical correspondence to the physical object will become obstructive rather than instructive. Nevertheless, for many years, the marketing story behind the desktop metaphor was taken seriously, despite the fact that Allen attempted to improve the Macintosh design with more elaborate visual analogies, as in General Magic. Microsoft Bob subsequently filed. The desktop can be far more profitably analyzed and extended by understanding the representational convention that it use the size and position of icon and windows on the desktop has not meaning they are not connected and there are no visual perspective, so it is neither map, graph, or picture. The real value is the extent to which always secondary notation, with the user creating her own meaning by arranging items as she wishes. Windows broader spread area of the screen into different pictorial text or symbol. Context as in the typographic page design of the textbooks or magazine, I can use the large variety of the convention to the indicate symbol correspondence to software operation and or company brands, but they are only occasionally or incidentally organized into more complex semiotic structure. Summary theories of the visual representation rather than theory of visual metaphor are the best approach to explain the conventional Macintosh Windows desktop. There are huge room for improvement. Unfilled theories of the visual representation. The analysis in the lecture has addressed the most important principle of visual representation for the screen design. Introduced with example from the earlier history of the graphical user interface, its most case, this principle has been developed and elaborated within whole field of the study and professional skill. Typography, cartography, engineering, and architectural drawing, arts criticism, and semiotic. Improving on the current convention requires serious skill and understanding. Nevertheless, interaction designers should be able, when necessary, to invent new visual representation. One approach is take a holistic perspective on the visual language. Information design, notation, or diagram, especially research community in this field address many relevant factors from low-level visual perception to critique of visual culture. Across all of them, it can be necessary to ignore or not be described by technical and marketing claims, and to remember that all visual representations simply compare smart and on the surface that are intended to the correspondent to thing understood by the reader. The two dimensions of the surface can be made to correspond to physical space in the map. Two dimension of the object to the pictorial perspective or to the continuous abstract scale time or quantity. The surface can also be partitioned into regions that should be interpreted differently. Within any region, element can be aligned, grouped, and connected or contained in the order to express their relationship. In each case, the correspondence between the arrange and the intent interpret- interpretation must be understood by convention or explained. Finally, any individual element might be assigned and meaningly according to many different semiotic principles of the correspondent. The following table summarizes holistic view as introduced above, drawing principally on the work of Bertin Richard, Mark H. Ren Blackwell, and Angel Hart and Angel Hart. This is a table. Marks graphic research, shape, orientation, size, texture, saturations, color line. Correspondent literal visual imitation of the physical filter, mapping, quantity, relative scale, conventional, arbitrary. Design uses mark position identify categories, shape, texture, color, indicate direction, orientation, line, express magnitude, saturation, size, length, simple symbol, and color code. Symbol, geometry element, letter form, logos and icon, picture element, connectivity element, correspondent topological linking, depictive pictorial convention, figurative metonym, visual fonts, connotative professional cultural association, accurate special literacies. Design uses text and symbol calculation, diagram element branding, visual rhetoric, definition of regions. Region alignment grid, border and frame, area filled with white space and gestalt integration, content separation, framing composition, photography, layering. Identifying share membership, segregating or nesting multiple surface convention in the panels, accommodating label, caption, or legend. Surface, the plain material object on the which mark are the imposed paper stone, mounting, orientation, and display context display medium. Letter map, Euclidean scale and angel, metrical, quantitative X, juxtabox and ordered region catalog, image schematic, embodied situated, typographic layout, graphs and chart, relational diagram, visual interface, secondary notation, sign and display. As an example of the how one might analyze other working backward design, a complex visual representation considered the case musical score. This consists of the mark on the paper surface bound into multiple page book that is placed on the stand at the arm length in the front of the performer. Its space is vertically divided into number of regions, visually separated by white space and green alignment cue. The regions are ordered within that the top and the peak coming first. Each region contains two quantitative axes with the horizontal axis representing time duration and vertical axis speed. The vertical axis is segmented by line and category pitch class. System places at the given x, y location indicate a specific pitch sound to be initiated at a specific time. And conventional symbols indicate the duration of the zone. None of the elements use any variation in the color, saturation, or texture. A wide variety of the text label and annotation symbol the U are used elaborated this basic element. Music can be and is also expressed using many other visual representation. See Dwignan 2010 for the survey of the representation used the digital music processing.